Hi everyone, in this video we will have a look on how to connect the ME131 Energy logger meter to a Raspberry Pi and read values from it through RS485 using Node Red. Okay, so just a quick overview of what we will be doing in this video. So firstly, connecting the ME131 to your computer with USB to a serial converter, and then configuring the energy meter with the supplier software, and then reading values using Modscan, and then how to connect the logger to your Raspberry Pi, and opening up Node Red, setting it up, and then finally reading values with Node Red. Okay, we will need one of these USB to RS485 converters. It's relatively quite expensive and easily available at all the online shops like Amazon. Just converts USB to RS485 and yeah, it's used quite often in electronic communication. Power to the energy logger and then the converter to your RS485 port. So just to have a look in more detail, so just make sure your port B is connected to port B and A to A. Port B is negative and A positive data for it, and the RS485 port. Okay, so once you've connected the USB the serial converter to your computer, the next step is to figure out on what COM port it is installed on your computer. So to find that out, you must open up Device Manager, then go to ports, and you'll see the two ports there. Okay, so if you plug the USB converter in, it will refresh and you'll see serial port COM port 8. Okay, great. So now that we've got the meter connected to our computer and we know what port it's connected to, we need to set it up or check the settings from the Mutual Assistant. This software is available for download on our website, and it's used to configure Mutual energy loggers. So first step is to select your COM port, which is COM port 8, and then the baud rate 9600, which is default. Parity is none, device ID 1, and then if you click on this small green button, it will open the port. Here at the bottom you will see COM port 8 opened, and then you can use this software to configure various settings. So firstly, select the correct meter here, and then you can set single phase or three phase and the amount of connectors, frequency, nominal voltage, and so forth. On the second tab, if you give it some time, it will read all the values from the meter. So if there's any voltages or current connected, you'll see that here, and you'll see the current settings of the meter. And for testing purposes, we'll be using the serial number. So I'll note this number down and see if we can read the same value through Modscan and through Node Red. Okay, to test the reading of registers through Modscan, through the serial port, we're going to use this tool, Open Modscan. It's a free version that you can download from GitHub. So if you just go to this URL and then click here on the right, and then download the selected one for your operating system. Okay, great, and then install it. Okay, so once it's installed, you can open it up and it will look like this. So again, you go to connection, connect, and select the correct COM port. Again 8, and then your baud rate and all the other settings must be the same as this, and then click OK. Okay, so if you get valid slave responses, if that counts up, it means you've connected successfully. Okay, so now we want to read the serial number of the device. For that, we'll have to look on the manual at the register list and see at what register is the serial number. Okay, so if we have a look in the ME131 manual, on page 28 is the register list that's readable. So there's different data types that can be stored in the register. So if you have a look down here, the serial number is stored in register number 70. You can read it. It's 2 bytes long, and it's an unsigned integer of 32. UN32, unsigned 32-bit integer. Great, so let's go back to Modscan and type in 70, and down here you can select different data types. It's very difficult to see, but what you can select unsigned integer. Just hover your mouse over it and you'll see the description. So you get a swapped unsigned integer and a swapped 32-bit integer. So let's select that, and it comes up with this value. Or it comes up with this value. And let's see if that matches our serial number that we read from the software. Okay, great. So let's see if we can get the same value in Modscan that we read from our application, configuration application. So this is the value we got from our configuration application, and this is the value I'm reading in Modscan. So you can see 2424 and the rest, and it's all the same. So important to note here is that if you want to read register 70, we need to actually type in 71. There's an offset with 1 here in Modscan for some reason. I think it's 1 based instead of 0 based, so just take note of that. And we need to read 2 registers, and the function code must be set to holding registers, and also your data type must be set to swapped unsigned 32-bit integer. If you select anything else than that, like just 32-bit swapped 32-bit integer, it will not give you the correct values. So it must be a swapped unsigned integer to give you the correct values. Great. So Modscan is a nice tool to debug Modbus communication, and you can see here if you're getting the correct values, and then use these settings to read values in your own application. Okay, great. So now that we know we can read the correct values using Modscan, let's try reading it on a Raspberry Pi and Node Red. Okay, so I connected the stereo port to the Raspberry Pi, disconnected from my computer and connected it to the Pi, and the setup looks like this, with the A and B connected to RS485 port. And let's go to Node Red. Okay, so I accessed my Raspberry Pi on this IP address, and to access Node Red you have to use this port, and then it will look like this. And okay, so the first step is to install the Modbus nodes. So to do that, go here to Manage Palette, and then go to Install and search for Modbus. Okay, and the one we will be using is the Node-Red-Contrib-Modbus. Okay, so I've already got installed, but you'll just click on that install button and it will install it for you. Okay, so once you've got that installed, on the left here, do a search for Modbus, and you'll see all the nodes rated to Modbus coming up here. So we'll use this one, Modbus read, and this red arrow indicates, or triangle indicates, it's not been configured yet. So to configure it, just double click on it. And then you have to first specify the server and then the address you would like to read. So let's add a server. Okay, I already added that one, but you can click there to edit it, and there you can select it not to be TCP/IP, but serial or serial expert. Just shows you a few bit more settings. And then if you click on the search button here, it will automatically list the USB port, the serial converter, the TTY converter it picked up. And there we select RTU buffered, baud rate 9600, the same as in Modscan and the configuration application. Data bits 8, stop bits 1, and parity none. And important here is also your ID of 1. And you can just click update or save. Okay, so that's our server defined, and we want to read again register number 70, and we like to read 2 registers, and let's read it every 1 second. Great. Okay, click done and save, and then click on deploy. Yes. Okay, the reason why it gave us that error is because we haven't selected the function code, and we want to read a holding register. Okay, so select holding register and then click done and then deploy, and then it should go without any errors. Okay, great. So now if you click on this button, it should read successfully if everything's fine. So let's see what it read by using a debug node and selecting the topmost port, not the second one. So if you click here and you go to information, you'll see output 1 is a data array and output 2 is a response buffer. So we want to use the data array. So select the top node connected with that connector and switch to the debug window, clear everything here, deploy, and see what we get. Okay, great. So let's stop that for a moment. Okay, so let's change the reading interval to 1 minute, just to make it easier to read here, and then deploy that. And if we can also click there to trigger it, and then we see the 2 values we get is 37,000 and 2. So that's the 2 registers that it read, and that's the 2 values that we got back. So you'll see that's far away from the number we're expecting, because this is the raw bits that's coming through in the swapped format, and we have to do some conversion to get it to the right value, which we will do now. Okay, great. So to convert these values to the expected value, we need to make use of this node called buffer parser. Just drag and drop that, and also from the top node connected there. Okay, and here we must say it's an unsigned integer little endian. So unsigned integer LE. So that means the most significant bit is sent first and then the least significant bit, other way around. Like in some languages as well, they say first the most significant bit number and then the least significant number. Okay, and we need to swap 32. Select swap 32 and select done. And let's just add another debug node there. And just clear this and deploy. And if we run it again, you'll see here the correct value, 2483, and the rest. Okay, great. So here we've seen how we can read serial numbers from the energy meter, just as an example, but it can also be applied the same principle to read voltages, current, and any other values. And then from here on, we can develop it further to display it maybe on the web page or log it to a CSV file, and then analyze the data from there. Great. So thank you for watching. I hope it's been useful, and till next time.